to this video lesson on BloodHound. Now we'll begin looking into different tools that can analyze Active Directory and find misconfigurations which we can go and fix before a potential adversary can discover them. BloodHound is a really famous tool which can reveal hidden and often unintended relationships in Active Directory. And by relationships, what we really mean is, imagine a path where a user can have force change password of another user who is member of a privileged group that can log into a server. The entire chain of sequence is something that BloodHound is really good at, can discover and then showcase back to us in a very easy to understand form. With BloodHound, we can go scan our environment and identify those paths, because in a large organization, it's very often the case when one administrator might leave delegations or add groups to be members of groups to get a very big list of merged groups or nested membership, that you completely lose track of who is member of what. I have seen environments where domain users in a 5 or 6 layers nested grouping was member of domain admins, simply because administrators had no easy way to identify the entire chain or follow who is member of what. And this is where BloodHound comes in handy. For attackers, that could be great because they can see if a compromised user has any rights across the rest of the network just in one simple view, while for defenders, we can go and see those exact paths as well, but instead of abusing them, we can fix them. BloodHound consists of 2 different parts. The first part is an ingester. The ingester you would use to go and scan your environment, collect data, and that data will contain a lot of information. For example, it will extract information about every group, every user, the relationship between them, what group is a user member of, what group is a member of another group. You have the entire information of everything from Active Directory. You also see what access control lists objects have on each other. And one example would be a group that can change passwords of every user, or a group that can write certain properties of a user, or a user who can read lapse passwords. This can be really many different things. And the great thing about BloodHound is that it will extract all of it. We'll have it in one really easy overview at the end. And the ingester, initially it was a PowerShell script, but performance-wise, it was really slow. So what the developers did is they re-implemented the tool in C# that significantly improved the speed of gathering this data. And the tool rebranded now in C#, the ingester part of it is called SharpHound. You can download BloodHound and SharpHound from the links which are provided on the slide currently. They're free for use, they're available on GitHub. Now, the second part of BloodHound is essentially a database with a nice GUI. And that GUI is the part which would display back to us the results that were collected. Essentially, it's just a visualization of all the relationships which were discovered. And we can also do custom searches. One such example would be if we take a user in our environment called Slavi and search if Slavi has a way to become domain administrator. That could be because Slavi has access to server 01, where a domain administrator is also logged into. Then if Slavi logs into server 01, he can perform a credential theft attack, for example, dumping credentials from the LSAS process and obtaining the password or the password hash of the domain administrator account logged in there. Then Slavi can essentially escalate to become a domain administrator by abusing credential theft and the domain administrator account who is logged into the server. Now, let's take a graphical view. We have executed BloodHound into the environment and we extracted a lot of data. What we did a search of is, can Johnny become a domain administrator? So what we can see here in the diagram is that Johnny has generic write access over the account exchange ADM or x_ADM. Generic write access can give or will give the ability for Johnny to change quite a few properties of each ADM, including the password. But you as an attacker, you'd probably not go forward to go and change the password because you make a user aware that something's wrong. Another way to approach this is Johnny, with his generic write access, can add an SPN value to the Exchange ADM account. And by doing so, this account will be potentially vulnerable towards Kerberos roasting, which was one of the first attacks which we discussed in this course. So if Kerberos roasting is now in play, we can extract a Kerberos ticket that we can crack offline with our password cracking tools. By doing so, if we successfully crack the password of Exchange ADM, we can log in as that account. And then going forward from the diagram of BloodHound, when we have compromised Exchange ADM, that account is member of SG_Azure Sync. And this group, SG Azure Sync, in Active Directory, you can actually see that users are shown as a green single user identity, while groups in the diagram are multiple identities shown in yellow. So SG Azure Sync is a group, and that group has certain rights on the domain object. And these rights will give the ability to this group to add replication changes permissions to any user that this group desires. So if Johnny compromises Exchange ADM through Kerberos roasting, he can add himself or he can provide himself the ability to perform DCSync by modifying the domain object els.bank. With the DCSync rights, then Johnny can obtain the password hash of any of the domain administrator accounts. And in this case, BloodHound shows that one of those accounts could be, as an example, the administrator account of the domain. So essentially, yes, to answer our question, Johnny has a path to escalate himself to domain administrators. And that path goes through changing the password or cracking the password of Exchange ADM and performing certain changes in els.bank. Now, let's go into the environment and go through the entire process of executing the ingester of BloodHound, and then analyzing data so you can get a better view of how to use the tool. I'm now connected to the environment, and we're going to simulate that. Let's say we don't know anything about this Active Directory at all. So what we want to do is, from the perspective of an attacker, although we're more really defending in this case, let's just take the perspective of an attacker who has compromised this user called Slavi. I'll just do who am I. I'm user Slavi in the domain production or prod. So I went forward and I downloaded SharpHound just so that we don't have to go through that process together. But everything from now onwards, we'll go through and do it step by step. So I have downloaded SharpHound and I'll execute it to get a help menu. Now, we're not going to go through each of these different options. The one that I really want to outline is the collection method, or you can specify just C. The collection method tells SharpHound what exactly do we want to obtain from the directory. And my really common recommendation here is that we should go for everything. We want to obtain all the information that this tool can get because we want to identify all paths. Now, getting this data and not being stealth, will produce a lot of noise into the environment. And that's also a good thing from defending point of view, because if you have monitoring in your environment, you will be able to detect this SharpHound tool requesting a lot of LDAP queries. One way to detect it is by using a tool, Azure ATP, which we're going to discuss later in the module, or you can set up additional logging at the endpoint, which can detect LDAP queries being created from the endpoint towards some of the servers. And for example, some of these queries which SharpHound is also going to create are who are members of the group domain administrators. And that LDAP query is not normal occurrence, or it's not something normal that you'd expect from an endpoint to create. If you see someone from an HR or marketing department making an LDAP query asking who is member of domain admins, that is really suspicious. So we're not really going to detect anything in this case. We'll just go forward and extract data. What we're going to do is we will specify that we want the collection method to be all, simply because we have a small environment. But in a big enterprise environment, you should specify collection method all, and separately you should also define session loop that will enumerate sessions over time. So for example, you can extract all the data as of now at this moment, but let the session loop run for another day to extract sessions in different servers that users are connecting to throughout the entire day, and not just at that specific moment who is connected where. So we'll just execute SharpHound with -c all for all collection methods. And I'm getting a network error. I will debug the network right now. I'll pause the video and then I'll resume when I have figured out what is causing this issue. So I looked around and it seems that there was not really any issue at the point something was wrong with the DNS. But if we run it now, we'll see that SharpHound starts collecting data, and it's really that fast. All the data is now collected. And that is because, of course, we have very small environment. If your environment is 10,000 or more objects, you would expect it to take a longer time. When BloodHound finishes, it will create this zip file. And this zip file is now all the extracted data that we need to move into the second tool of BloodHound, or the virtualization side of it. This was the ingester collecting the data. Now we'll move the zip file into the other tool that can visualize it to us. I have the second part of BloodHound installed on a Linux machine, so I'll switch to the Linux machine and move the file. I'll pause the video while I'm switching and then resume it when I'm at the Linux machine. Alright, now we're connected to the Linux machine and I have already started BloodHound. This is the GUI and you're going to become very familiar with it once you start working with the tool yourself. The first thing we have to do is go and upload data. So we're going to upload the zip file. You have to select just the zip file itself, and the tool will automatically unzip it and take the different text documents which are inside. So it will go unzip the files, process the data, and then just show us the output or a summary of what it found. So there are 7 users in our environment, 3 computers, 65 groups, 2 active sessions where users are logged into computers. There's certain access control lists between objects and some relationships. We can start and search for a computer or a user in here, or we can also go into the queries section, which comes with some pre-built queries. For example, we can state or just click on the one that says find all domain admins, and it will visualize the domain admins group to the right and everyone who is a member of it. So what we're going to see here is that we have 2 members. One of them is the account called administrator and also the domain controller. And it's really weird that the domain controller is a member of this group. This is not something custom. And actually this would be a misconfiguration that we need to look into and potentially mitigate by removing the domain controller from being a member of this group. But aside from that, we have the administrator account, which is a domain controller. It's a domain admin. The built-in queries can also identify certain paths. So for example, show us all the different paths from user or computer to become a domain administrator, if there's any relationship between that. To use any of these queries, we can specify what edges we want to be part of that. So do we want to consider the fact that the user can RDP to a server as a jumping spot for BloodHound to detect that relationship or not? And in this case, I don't want to see points where the user has the RDP ability, but it's not a local administrator of that machine. I want to see all the different access control list edges that BloodHound can detect, such as write or generic all, generic write, if certain users own objects. That is something I would like to discover, or if they're a member of, if they have session to, if they're administrator to, and so on. I'll let you play with the different built-in queries yourself so you can see how valuable they can be. But instead, what I'm going to do is I'll specify a path that I want to look for myself. And the path is if I could start from the compromised user called Slavi, and can I use that user to become a domain administrator? Is there a path? So running that query returns an output, which means that BloodHound has indeed detected a path. So let's look into that. What we're going to discover here is that the account Slavi is administrator to server 01, where currently the account administrator is logged into. And the administrator account is the account that we already discovered has domain admin rights. So if Slavi, my compromised user, if I could abuse that user to go to server 01, I can perform credential theft and compromise this administrator account. By doing that, I will escalate my privileges to those of domain administrator. Now, there's something really interesting about BloodHound, because since it has all the data about all users in all groups, it can also visualize it to us. So, for example, if I press on the account Slavi, on the left-hand side, I'll see all the information that BloodHound extracted about this user. And that would include the seed value, when the password was last changed, when the user last logged on, whether the user is enabled, disabled, the description field. What is interesting here is that you see that in the description field, it contains pass_welcome1. That could potentially be the password of the user, which is another misconfiguration that might exist in Active Directory. But there's much more than this, because it will also create a summary of the groups that the user is member of, and you can directly press on these numbers, so you can see that, for example, Slavi is member of the group domain users directly, but indirectly he's member of 5 groups. So if you press on 5, we'll see that the direct membership into domain users starts to expand into other groups as well. And then the account has local admin rights into one computer, and we can see which computer that is immediately. If we do derivative local admin rights, we'll see that there's a path for this user to escalate their privileges to essentially derive local admin rights on 3 machines. And if you remember, the 3 machines were all of the machines we have in our environment. And there's much more that can be shown here, really. It's just a matter of identifying having a bigger environment to have these populated, so you can see how valuable they can be. And one thing of the queries which I mentioned before earlier was that the pre-built ones can detect and showcase quite a few things. You can also create custom queries into the language of this database. It's using Neo4j in the backend. So if you're more familiar with the language, or there's also cheat sheets of the most common queries that you can have already pre-made in that cheat sheet, which you can just plug in and use in here. But if we run the pre-built one called find shortest path domain admins, it will essentially identify all paths that exist towards domain admins without a starting point. So the one that's interesting here is that if we go all the way to the left, we'll see that there's a path from Slavi, who we already discussed earlier, through the administrator account. There's also a path for account operators, because account operators have generic all rights on computer objects. So a member of this group, right now there's no members. If you click on the group, we'll see that there's no direct or indirect members of the group. So if there was a member of this group, he will have the ability to alter the computer object and escalate their rights to domain admin again through the same path that the Slavi user can. I really hope that this short video and demonstration of BloodHound can showcase how valuable this tool can be, and not just for attackers but also for defenders, to identify these escalation paths and essentially stop them, implement something that mitigates the escalation for these users.